Welcome to Semantic Web Technologies. This is Lecture 2, Semantic Web Basic Architecture Part 1. And this is Part 2 of the lecture. And here we want to talk about how to represent facts in the semantic web, simple facts with the help of the so-called resource description framework. And this is the first introduction to RDF. But let's start somehow earlier. In the early days of the web in 1994, at the first www conference in Geneva in Switzerland, Tim Berners-Lee, who is also the inventor of the World Wide Web, stated that web pages on the web do not only represent a network of documents, but with these web pages, of course, information concerning real-world objects are described. And of course, these real-world objects have connections among each other that are also represented by the connections that these documents have among each other. And this might be considered as the core of what we today are referring to as the web of data or the semantic web. So what we are doing now is we are going a little bit up in the technology stack of the semantic web architecture, and we will talk about the representation of simple facts of knowledge, and this can be done with the resource description framework, and it's here the blue layer for information exchange. So, how do I represent facts? Let's take a simple fact. Let's say I have the telephone number that you see here. So, how should I represent that? So, let's take the case you know a little bit XML, which is the extensible markup language. And with the extensible markup language, of course, you can denote semi-structured information. And for example, you can say you define a phone number, and a phone number has an owner and a number. And this should denote that this owner has this phone number. Yeah, but on the other hand, you can also define a person. And then you can state a person has an attribute, for example, a name, and it has a property, a person has a phone number, which you can see here. And think both of them are somehow expressing a similar thing, while they are quite different. You can make it even shorter. You can define a person with two attributes, with a name and with a phone number. The problem is all this denotes the same, but how to decide that really the same information is inside this semi-structured information? So the question is there a unique and intuitive way to model knowledge? I would say, of course, there is, and we are used to, because we are using natural language. So for example, I can say that I have a phone number, and the number is this. So it's pretty simple. It's 3 parts. And you can represent these 3 parts simply, for example, with a graph, which is pretty intuitive. So, for example, here, the first node of the graph, that's me. The second node of the graph, that's the phone number. And I make a connection between these 2 nodes and say, this node is connected with the other node. And the connection itself has the property that it is the phone number. So I have the phone number that you see here. So the general concept that we are talking about now is that previously with XML that is available in the web to define schematas, we can define simple objects, but they are not connected with each other, and it's difficult to decide whether they really represent the same or are different. One level above there, we will have the possibility to define relations among these objects. And these are first knowledge, first facts that we can express, that we can take objects into relation with each other. And we can construct little worlds that are open and that are based on the resource description framework and the resource description framework schema language. And to go one step further, if we want to close our world and want to define an entire world with things inside that world and want to state facts about these things inside that world, then we have to go one step above, and we have to enable greater so-called semantic expressivity with the help of the so-called web ontology language and with rules. And with that, we can formulate axioms that contain knowledge, restrictions, and constraints about these things that we are talking about and that we have defined one level below. So in these 3 steps, we will build up semantic knowledge representation for the semantic web. And first, we start talking about RDF, the Resource Description Framework. It's pretty simple to state facts in RDF. So first we have resource. Everything in principle can be a resource, and resources are, in our sense, identified via URIs. So a resource is always associated with an URI that we have already known. On the second hand, of course, we have to describe resources, and we describe these resources with the help of properties that we define, that these resources might have, and with relationships among those resources. And as we have seen, these relationships can be represented as graphs. And, of course, RDF provides a so-called framework, so it's a combination on web-based protocols, on URI, HTTP, XML, and it's based on a formal model. It means it has a formal semantics that is well-defined and that is sound. And this allows us to define relationships among resources and to handle this knowledge with the formal semantic in a way that we can deduce new knowledge from implicitly hidden knowledge inside this resource description framework. So, let's come back to the fact and to the example that we had in the beginning. So we had there that I have the phone number that you can see here. And this is a simple sentence. And of course, I am the subject. This here is a predicate or property. And this here denotes an object. So, knowledge in RDF is simply nothing else than a list of statements that are expressed somehow in this way. And all these statements follow a pretty simple schema. It's the schema of subject, property, and object. So we are talking about resources. Subject and object can be resources, of course, and these objects can be addressed via URIs. And the property, this is nothing else than the attribute for the description of resources. This is also a URI, or we denote the property with an URI. And this property can have a value, and the value might be another resource, or it might also be, if it's descriptive data, it can also be a string or simply characters. So then it's a so-called literal. So RDF triples are composed from 3 parts: a resource, which is a URI, it's the subject, then a property, which is also an URI, and then you have an object, and the object might be a URI if we are referring to another resource, or it might be a literal when we refer to a string or to a value that has an associated data type. So, this is a simple RDF graph that you can see here, and we try to state the fact that I am represented via a URI, that I am, for example, writing a blog. This is also a URI. And the blog that I'm writing is here a resource that also has an identifier on the web, a URI. Or if we come back to our first example, to the telephone number itself has no URI. It's, let's say, a character string. Then this is a literal. It's only a character string. It is not its own existence, not a separate existence. It's only a property of myself. And then I can say, I myself, I am this subject and this URI. I have the phone number, also here again the URI for the phone number, and then I can state this is the phone number I am referring to. And this, in the case, is a literal. And a literal can be various data types, and usually it's a simple string. Also, of course, I can use data types, and data types I can reuse things that can be expressed via XML schema data type. So I have to include into my RDF document the namespace for XML schema literals, pretty simple. And then I can state this is a literal. So I have here quotation marks, semantics, and then I have to add the URI of the data type I am referring to, and this is then the namespace for the XML schema data type, and then hash as a fragment identifier, and then the string I am referring to. And secondly, of course, these strings can be given in different languages, and I can also make clear which language I am using, and then I can add to the string here, to the literal, also a language tag. And these language tags are encoded in 2 characters. So for example, if I'm referring to the English language, it's EN, or if I'm referring to the German language, to Deutsch, it's DE. So pretty simple. So let's keep in mind literals are usually strings or can have data types that can be expressed via XML schema data types. And on the other hand, strings might be given in different languages that can be denoted via a language tag. Another interesting constituent of the RDF graph, besides resources and besides literals, are so-called blank nodes. So I can have, for example, a subject or an object that has no URI associated with it. And then it's a blank node, an empty node. And this simply denotes the existence of some individual that has specific properties or has specific individual attributes. But I do not denote which individual this is. I do not give it a name. Sometimes it's pretty convenient also to make a statement about things that exist without telling which individual directly I address with this information. So for that case are blank nodes necessary. Okay, so we have 3 things in mind. We have first resources we are talking about, given as URIs. We have literals, maybe strings or data types, and we have blank nodes. And these are the constituents of RDF language. And then we have several different representations of this language. So first representation we have already learned is that one. It's the so-called node edge node triple. It means it's a graph representation. Second representation is the so-called N3 notation. You see here a triple given with its 3 URIs. So we have here a resource, a property, and here the object it's talking about. And this triple in N3 notation, there the 3 constituent parts are separated via comma, and they are in curly braces. So this is the N3 notation. But this gets, for longer and more complicated knowledge, pretty expensive. For that case, one has a simplification of that N3 language. This is called the turtle language. It's the terse RDF triple language. This is an extension of N3, and it uses URIs in angle brackets that you see here. Then literals are given, as you see here, in quotation marks, and every triple ends with a period. White spaces within the triple will be ignored. So you see here, simple subject property object triple with a resources object, and in the second line you see the same triple with a literal as the object. So, in Turtle, simple triple or simple statements in RDF will look like that. And you will see here the URI that denotes me, then a URI for a property that denotes that I'm writing a block, and this is the URI of the block I'm writing. So again, subject, property, object. And here again is the triple that states that I have a specific telephone number. Now you might think, oh my God, for each of these simple facts, I have to give these long URIs. Of course you don't, and there are shortcuts for that. So for prefixes in URIs that you use rather often, you have some ways to define a certain prefix. So for example, for the XML schema, you define here a prefix in Turtle XSD, and this denotes the prefix of the URI that you see here. Or you define the prefix DC, and this is the prefix for the Dublin core namespace. And here it's the prefix EX, it's an example namespace. And then you refer to these prefixes in these URIs you see here, and there simply DC is substituted by the full URI, and you don't have to write the full URI here, and then of course it becomes much more readable. What you see here is in the end you have here the subject we are talking about. It's that here, that URI, and you say this one has a title, and the title is this string here in quotation marks, language is English. And then you go further because you can continue to state something about that subject, and then you don't close this with a period but with a semicolon, and then you say this subject has a specific editor, and then this is something new. We will go through that in detail. We will open up these braces, and thereby we define a blank node, and in this blank node we have again property and object, and here we have a name, and here we have a home page. So it's pretty simple representation. Of course, you can also use an XML-based representation of the same facts, and then, as you can see here, it becomes less readable and you have to write more. But this RDF XML serialization, it's the standard for each web document. So you can embed it pretty simple into the web because XML can be read by most text processors and parsers. So this is the norm or the standard. But of course, there are ways to translate automatically between these different syntaxes and languages. So it's no problem to translate this, but you should keep in mind that you can also read and write RDF in XML serialization. As you can see here, it looks much more complicated. This, of course, is an XML file. Therefore, you have to have this XML tag. And then you define an RDF document via these RDF markup tags. And there you define two new namespaces. First, for the RDF namespace, so you don't have to repeat it for your RDF markup tags, and then you have here, for example, a personal namespace, and here you are referring to these namespaces again and again. And then here, for example, you are talking about a subject about me. You encode this in RDF about, and then I can say I have a phone number. You state this phone number here between these markup tags, and you make an RDF description, and this describes again a triple. So it's a little bit more complicated. You have more to write, but we will go into that into detail in the next part of the lecture when we are talking about how to represent simple facts with the help of the RDF language that we have learned to know right now.